Now the topic is class A commutation, right? So before going for the explanation of waveforms, let us discuss on mathematical analysis of this particular class A commutation, right? So class A commutation is also known as load commutation, right? Load commutation, it is also known as what? Load commutation, writing here. Load commutation, right? So this is a circuit diagram we are having, as it belongs to the forced commutation circuit. It is excited by the DC supply itself, and we are having an SCR, and L and C are the commutating elements, and there is a resistor, right? So when we are going to give some kind of supply, definitely what is going to be happen? A current I naught will be flowing inside this particular loop, right? So I naught is given as Vs of t by z. So if I'm going to apply the Laplace transform over here, so I naught equal to Vs of t, the Laplace of Vs of t will be Vs by s, and z is nothing but what? R plus L plus c, right? Total of z. So R plus Ls plus 1 by Cs. This is a Laplace application, Laplace transform. I hope you people know, right? So if at all I am going to solve this particular equation, so this particular equation can be changed into I naught equal to Vs by L by by s square plus R by L into s plus 1 by Lc. So if you clearly observe this represents the characteristic equation, right? I have written over here. This represents the characteristic equation s square plus Rs by L plus 1 by Lc equal to 0. So if I am going to compare it with the standard characteristic equation, second order equation that is we have been studied in control systems, s square plus 2 zeta omega ns plus omega n square equal to 0. So from this, if I compare these two particular equations, omega n square equal to 1 by Lc, that is what I have written here. So from here, omega n equal to what? 1 by root Lc. Understood over? Next, 2 zeta omega n equal to R by L here. So from this relation, I can substitute the omega n value over here, and finally I got the equation like zeta equal to R by 2 into root over C by L. This is what I got. Understood or? So if I am going to talk about the stability of this particular thing, so I need to go for taking the underdamped system. See, if underdamped, how can we say it as a stable one? So we are having lots of oscillations at the beginning, and finally the oscillations are going to be getting. So that means what? This is an underdamped system, and for an underdamped system, as we have been studied in control system, for an underdamped system, zeta is less than 1. So if I am going to substitute the zeta, what is the zeta value over here? This is R by 2 into root over C by L. If I substitute the particular condition, I am going to get the equation like R square is less than 4L by C, right? So when I am going to turn on the SCR, right, by giving a gate pulse, what is going to be happen? So up to pi, there is a positive half cycle, so definitely what is going to be happen, the SCR will be conducting, but after pi it is going to get reverse bias. So here the SCR is going to be 0. So for an underdamped system, the resonant frequency here given as omega equal to omega, not underdamped system. For a resonant circuit, the resonant frequency is omega equal to omega into root over minus zeta square. So the maximum conduction time of SCR, right? So but before going to this particular thing, I need to consider one thing, that is to turn off the SCR, anode current should be less than holding current, and SCR can stay on during 0 to pi. I am saying you 0 to pi itself, the SCR is going to be stay on. So what is going to be happened over here? So maximum time of the conduction time of the SCR is given as T omega, that is how much it is conducting from 0 to pi it is conducting, sir. So it is going to be pi. So that means what? T equal to pi by omega, what we are having the resonant frequency value. This is what resonant frequency value. So from this we can calculate the maximum conduction time T equal to pi by omega into root over minus zeta square. So if I am going to apply some kind of firing angle alpha, then the turn on time of it, SCR for alpha firing angle is given as T equal to pi minus alpha by 1 omega n into root over 1 minus zeta square. So this much of mathematical analysis we are having in class A commutation, right? So let me discuss the waveforms of class A commutation, right? Yeah. So initially SCR is in off position. So when we are going to apply a gate pulse, then SCR will be turned on. So when the SCR is going to be turned on, then what is going to be happen? The voltage across the capacitor will charge to supply voltage Vs. So for example, let me suppose I have given a gate pulse at this particular position. right? I have given a gate pulse here. This is what gate pulse Ig. Fine. So if I'm going to calculate the Vc value, so this is what Vc. Let me suppose this is as I naught and this is Vt, right? So what is going to be happen? So initially SCR is off. When we apply gate quells, then SCR will turn on. So as the SCR is going to be turned on, then what I am saying, the voltage across the capacitor will charge to a supply voltage. So the voltage across the capacitor will charge to a supply voltage like this. Understood? Or so this is what the Vs voltage. This is Vs voltage. Voltage across the capacitor will charge to the supply voltage, right? So now at this particular condition, the load current also will flow. So load current will flow in the circuit and increases till the capacitor will reach the supply voltage. So the load current will goes to maximum until Vs, See here, this is the load current, it is flowing like this. So under these conditions, what is the condition? So the polarities of inductor will be like this and the polarities of capacitor will be like this. Understood? Or right? So now, so as the SCR is in on position, so what is the voltage across the SCR? So the voltage across the SCR will be equal to 0. The voltage across the SCR will be equal to 0. That's what I have written out here, right? So now in the second condition, what is going to be happen? So once the capacitor charges up to Vs, right? Once the capacitor charges up to Vs, the polarities of the inductor will change like this. So the polarities of the inductor will change like this, right? So that means what? Whatever the energy we are having in the inductor will be dissipated or will be discharged through this capacitor, right? Will be discharged. So how it is going to be discharging? So this is positive supply, so there is a discharging, like, let me delete it first. So so there is a discharging like this in this fashion. Understood? Or so that is so thereby what is going to be happen, as the inductor current is going to be discharged, so it is going through this capacitor, hence it will be what? It will energize the capacitor more and more. So thereby what is going to be happen, the capacitor will charge up to some extent further. So that means what? So this is up to Vs, so the capacitor is going to be charged up to some extent like this. Understood? Or now what is going to be happen from this particular condition? But at this particular condition, what we can consider, the output current will start to decrease and reaches to 0, and until it reaches to 0. So this is the condition. Understood? Or so until it reaches to 0 from this particular position, definitely the SCR is in on position. As the SCR is in on position, definitely the voltage across the thyristor SCR will be what? 0 again. Understood? Or so this is the condition. So when the output goes below the holding current, right, the SCR becomes off and the capacitor start discharge. So when the output current goes below the holding current, let me suppose little holding current, so definitely what is going to be happen? So the SCR will going to be get off, right, like this. So output current will be 0. Understood? Or fine. So the SCR becomes off and the capacitor starts discharging like this. The capacitor starts discharging like this. This is the condition. Understood? So finally, as there is no capacitor, so the voltage across as the SCR is in off position, so the voltage across the SCR will start increases. So there is an increase in the voltage across the capacitor. Fine. So this is all about what? Class A commutation. Simple circuit. Fine. Thank you.